with that being said, let's start. We're going to set some context about what this client situation was. What was the context before we go into what we did? Let's start there. If you zoom back like a 50,000 foot view, a Fortune 500 insurance and healthcare provider, chain of hospitals, and growing by acquisition, which is very typical for this kind of organizations. 200 plus umbrella of different legal entities that get acquired. Even during the time that I was on this client for the past 2 years, they made more than 50 new acquisitions. If you put your IT hat on, you can see the implications of that to your data at the organization. Like what happens when you buy a new hospital chain? What happens when you onboard a new kind of insurance to your IT? And they have a digital transformation journey going on. They have, which is also very similar to the other enterprises at this scale, which is, okay, we have the IT, but we also want some new way of thinking about technology. So we're going to take on the digital transformation and start a digital arm alongside the IT. Obviously, heavily regulated. The healthcare and finance together and insurance, I don't think it gets more regulated than that. And the organization was really interested in cash to innovation conversion. How can we do something innovative here to stand out from our competition when it comes to the usage of data? And that's how the introduction from this organization and Thoughtworks was made. The state of the data when we start our journey is very typical to a bunch of Fortune 500 organizations. You have an on-prem data warehouse, which is the de facto standard. This was an Oracle one, more than 35 years of history accumulated in that warehouse. Most of the organization mindset about what does data mean came from the design of this warehouse. They had multiple attempts at going to the cloud. Because of the scale of this organization, they had every flavor of the cloud that you can imagine, from hybrids, from all the three providers, but none of them had been became the standard. So when we arrived, they were still debating which one should they double down on and commit to. And as a result of this, any organization that was already in the cloud, because they were not cloud native, they had the different copies of this data warehouse in different locations. So imagine if you're a data scientist working on the cloud and all of your models and everything is on GCP, for example. If you wanted the actual data to get you started, you would go to the on-prem team and ask them to give you a copy of this data. If you're a different analyst in a different business group, you would do the same thing. You can imagine what would that do? How would the governance organization or the security organization think about these copies? Like, who has access to what anymore? How are we auditing this thing? They were very, very nervous about the situation. We'll get more into the governance section of how they were using this journey on adopting data mesh as a way to tackle this specific problem. Other than the state, the aspirations and what the C-level of the company wanted to do was change the viewpoint of the data to enable LHR. If you have never heard this word LHR, longitudinal health record, it's the North Star for a lot of people who are in the health data. If you're coming from finance background or from a typical organization background, you probably have heard customer 360, like I want a view of what's going on with the customer. But with health, it's different because there is no way that a single organization can know all of the health information of you throughout your life, throughout all the provider that you have been to, through all the insurances, all the jobs that you have changed. There is no way for that. So it gets much, much complicated to provide that longitudinal health record. Longitudinal just means if I look at Sina's data, I can see all of the history of the medication, history of the surgeries through different time. And in this diagram, it clearly shows where would we fit. So let's start from the top. The top is all the channels, like how you interact with this organization through the website, through the messages on your phone, through the apps, through the clinics. underneath is the LHR, which is answering member-oriented questions about, has this person have COVID? What's the history of health for this situation? What for this person? And underneath that, to enable that, are these domains and datas, which we're going to talk about, which is the main enabler for the LHR. Underneath that, you have the cloud platform, which is your utility layer, which is if you are in GCP, you have your big query and stuff like that. If you're on Azure, you have blob storage and ADF and things like that. And then under all of that, you have the infrastructure, which is the commodity hardware. Most of our work has been in the layer of enabling the cloud platform and building on top of that an abstraction layer for the data platform as capturing these different data domains to enable LHR. Just a lens of how would the organization were thinking about success in this area. And just to double click a bit more with more tangible detail, if you look at how they measure success, enabling data scientists to do their job, enabling analysts and citizen analysts, supporting strategic use cases. So when we started, this was before COVID, then COVID happened. Of course, COVID changed the situation for the enterprise massively. And a lot of effort went into how can we use COVID as a strategic initiative to grow and change and adopt this new way of thinking about data. You also see a lift and shift on key assets from the warehouse. One of the main focus of this organization was to do the cloud migration. As we mentioned, they have had multiple attempts on it. And as a result, they had a key metric around, these are all the tables in our data warehouse. I want these exact tables on the cloud. This turned out to be not a very good KPI, as you can imagine. We actually were successful in air quote in moving these data assets and do this cloud migration and do this lift and shift. But if you actually look at the impact that this lift and shift had on the organization or on the business bottom line, it was not that much comparing to the amount of effort it took to do this. Because as you can imagine, these tables on the warehouse had a lot of legacy in them, and lifting and shifting them without changing the culture of the organization is not going to be the most valuable efforts. At some point, we got to diminishing returns. One last thing about the context, the kind of questions that analysts and the machine learning scientists trying to answer. If you're coming from a health organization or insurance organization, this should sound very familiar. As an insurance, I want to reduce the cost of cancer treatment. How can I know about these things earlier? How can I promote awareness about these things? For members that are high cost, which is the most complex members, how can I reach out to them faster and better so that it doesn't get too complicated, better for the business, better for the member? How can I reduce the discharge costs when you go to a hospital and you get discharged? That's actually very costly for the organization. So how can we prevent premature discharges and things like that? And of course, the COVAX, which stands for COVID vaccine. Who is vaccinated? Who is not? How much of our population has had COVID and things like that. We are gonna use the COVID as an example because it's on the top of all of our minds in the past 2 years. As an example through this journey and look at all the different lenses through this example. So we're gonna talk more about that. That was it for the context. I think we can take a pause here and see if there's any questions on the context of this situation.
No questions so far, but I guess I would make a point that why we decided to share this particular case study with you and why this organization was a good candidate for using data mesh. As Sina mentioned, there was an immense amount of complexity in terms of number of domains, number of systems, number of teams through merger acquisition, through expansion of the business from insurance to provider. There was already a series of attempts that just tried to do lift and shift, which is very common for organizations that try to set modern data stack, right? Let's move it to the cloud. Let's move the data to the cloud. And that doesn't necessarily get to getting value from your data and have a bottom line impact to your organization. The other, I guess, factor contributing to the decision of moving to data mesh beyond complexity was this top-down support. From the CEO down, there were a series of kind of strategic initiatives that how can they, impact the life and experience of their members at every touch point with data, with ML. So if you look at just a squint at these few use cases Sina's put on this diagram, you will see that it's all about improving the life or improving experience, and of course, as a result, reducing the cost of operation for their business. But all of these cases are about using data insights, automatic decision making, predictive analysis to make better decisions, right? To take better actions. So there was a top-down strategic support from CEO down to the level that we were, kind of working. And in addition to that, there was a desire to put the right investment in place. So the organization that slide Sina had around kind of innovation, they had good kind of investment to innovate in the platform, in the technology that is needed. And you will see evidence of that. So that's combination of complexity, desire to innovate, getting value, have very clear understanding of how data can generate value and outcome, and that top-down support create this perfect storm for implementing data mesh. And of course, it wasn't all rosy and fun. There was a lot of blood and sweat and tears that we can Sina will share with you.
For sure. Let's look at the approach that we took, which should not be applying the data mesh to this organization. To Zhamak's point about why data mesh, and if you have been on this series of webinars, you probably have heard this word, you maybe have read the articles about this, but when we look at the gist of this, in a data warehouse, you build consensus upfront, you design your canonical model for the whole organization, and then, which is very hard, a lot of challenges and time goes and engineering effort goes into that. And then it's very easy to query the data after. The main pain point of the sad face that you see on the upfront was a pain point specifically in this client, because as they acquired more and more entities, growth by acquisition, and the type of data for LHR got more diverse, a lot of external data, this upfront step would take months, on average 6 to 8 months. And that was the main pain point of why they were looking at a different approach. The data lake on the other side tries to say, okay, I'm not going to do upfront design, put the data here, and then when I'm querying, I'm using the data, I will figure this out. Of course, the people who designed the data lake originally back in 2008, 2007, didn't meant it to be used this way, but in reality, that was the situation of the client too. Massive data lakes, very similar to data swamps, with not a lot of clear ownership and easy to use data. The data mesh tries to approach this problem very differently, decentralize this concept around the domains. Instead of having a canonical model for everyone, break this down to different smaller domains, let the modeling and the governance and the cataloging and all of those things happen in the boundary of a domain, and decentralize your operating model and architecture. That's the bottom line of what we try to do at this client. If there are 4 areas that we are challenging the status quo on this enterprise, instead of specialized data warehouse knowledge teams, decentralize that around your domains. Instead of data as a byproduct of transactional applications that are processing your claims, that are processing your encounters with doctors, think of data as a first-class citizen. Instead of jumping through a lot of complex technologies, and each of these cloud providers are introducing 10 new tools every month, instead of jumping through that, can we think of a self-serve approach and remove that complexity from the people who want to use and provide data? And instead of a governance team policing teams and penalizing you when you do something bad? Can we enable the governance team to become enablers for you? These are the four main areas of status quo that we wanted to challenge, which maps very naturally to the four principles of the data mesh: the decentralized domain ownership, the data as a product, self-service platform, and federated computational governance. You will clearly see that these things are not in isolation and they build on top of each other. Decentralized domain ownership, which means allowing the provider of the data to own the analytical data. This is an organization-focused effort. Think of this as a digital transformation kind of effort. It's an organization transformation. It's a different way of looking about how you organize your teams and how you organize your OKRs or KPIs, or however you're managing your business, which you can't really do that unless you are thinking about data as a first-class citizen, which is data as a product. And it's not just about data, it's also you need to think about the policies and code and infrastructure, all of the things around it. It's not only the table inside a database, it's not only a file and data lake. What about all of the other things that contributed to the data being in this shape and encapsulating this as a unit? Which, if you want everyone on the organization to do that, every domain to do that, you need to remove the complexity from them, because not everyone can go and learn Databricks and Azure Synapse Analytics and all of these complex technologies. You need some sort of abstraction layer to remove these complexities from them, which that is the self-service platform aspect of this. And in order for your self-service platform to become a thing and even being able to go to production, you need the governance to be embedded in it, which we're going to talk about, the federated computational governance. We're going to use these four lenses today and introduce them on a theoretical level of what do we mean by that, and then go into the actual implementation and a tangible example of how would that look like for each of these things. So let's start with the first one, which is decentralized domain ownership, which in practice means shifting the responsibility for analytical data from a centralized functional team like the data warehouse or the data lake team to the business domains that create and produce the data. So in this organization, you have many different business units who are responsible for different parts of the business. You have many different IT organizations who are responsible for the technologies that support these businesses. How can, instead of having a central data warehouse team, having these business units and the IT teams work together to provide the analytical data for the business? So let's go through an example of how would that look like. So let's go back to the original COVID problem. If you're trying to answer such a question of who has had COVID in this organization, what's the percentage of our population? And when I say population, I'm talking about the people that I'm supporting, the people who are using my hospital chains and my insurance. How is the COVID situation in this population? The answer to that is actually pretty complex. Like that, who has had COVID is not an easy question to answer in the health domain. You need data from the people. Who are these people? You need data from the claims that these people have made, what kind of coverage plans they had, and put all of this information together. I will give you an example here because of the challenges of health data. You may have had COVID or any other diagnostics and with a different provider and then switch this provider. Or you go to a different health insurance and pay out of the pocket. A lot of times when you're looking at if Sina has ever had COVID, you're going to see a bunch of bits and pieces of information, and you're not going to see a clear record that says Sina has had COVID. You may have to infer a lot of knowledge about this person is claiming all of these drugs. Probably with a 90% chance he or she has had COVID in this era. So that's the kind of questions that the machine learning data scientists and the analysts were trying to answer. But where does this information come from? Where does the coverage, the claims, the pharmacy, the drugs, the codes, the kind of drugs, the members, the provider, where does the information come from? Of course, it comes from the transactional IT systems. In this environment, you see a bunch of 4-letter, 3-letter acronym names on this slide, which are the providers of this information. Some of them are microservices and very modern. Some of them, I think 3 of the things on this slide are actually mainframes that are more than 40 years old that provide this data. And they are the source of truth for this information. Of course, in the land of the status quo, this information goes to a central team of a data warehouse, gets remodeled, and get provided for the analyst. In the North Star that we are trying to get to, these the people who know the systems in and out and know this data in and out and have been playing with this data for years are responsible for creating the analytical data of that. So if you are working on the transactional application, if you're responsible for maintaining that, and you're seeing day-to-day the changes that are happening to these transactional systems, because these are not also snapshot in time, they are evolving as the organization is evolving, you are in the best position to be able to say, if an analyst wants this data, they probably want it in this way. Or if we're going through acquisition and a new organization is being added to the source of the data, this is what it means for the meaning of the data to change. Even if the schema is not changing, maybe the meaning of the data behind the schema is changing. Who would know these answers? The people who are very, very close to the systems are going through that change themselves. This is, of course, the North Star. We are still on this journey, going toward this direction. The baby step that we took was enabling the role of a data steward, which are the key people who know these systems in and out, to sit between us, so extract them from these organizations that know this data in and out, and enable them to manage the life cycle of the data products that provide this to the users. And by managing the life cycle in here, I mean managing access, managing data quality thresholds, managing sensitivity levels, and double checking the semantic tagging and things like that on the data. Was this the end? Is this the end goal? Of course not. We want the picture on the previous slide, which all of these data are owned by this domain. But this is the first baby step, a tangible, moving the needle that we could do on this client, specifically with the constraint that we had. The main constraint that we had is we started our journey on this client from the tech angle. We started from how can we do innovation on the data from technology perspective, and a data mesh transformation requires sponsorship from the domains and the leaders who are on the business side and IT side to change their operating model. As I said, this is a very, very much organization-focused challenge. We found that the younger initiatives have much better success with this. So when we were doing some new data that's coming in, it's much easier to have those domains own the data on this on the platform and not go through a centralized team, versus if you think of an insurance or a provider, the core of it is claims. Like things like claims are very, very hard to move to domain because the mentality of everyone in the organization has been set very hardly on how it is in the status quo. And the last lesson learned here around the organizational impact, which is this has HR policy changes, organizational changes. So think about this. If you are going through this transformation, and of course, it's not going to be day one in one day, but there is no more data warehouse team. There is no more central data team. You are trying to get out of the way by providing the platform for the domain teams. Whoever in your organization, think about who is your domain teams, either the business units or the IT organizations who are managing the transactional applications. As a data team, you are getting away from this. You're removing yourself from this bottleneck and allowing them to provide the data to the consumers, which in our case was analysts and the machine learning data scientists, which has implications, right? Not everyone is going to be, yay, let's do this massive change. Before we go further, I want to pause a bit and see any questions about the domain-oriented decentralization.
Yeah, there are some good questions. So let me raise them, do my best to answer some of those, and hand some to you, Sina. There is a fantastic question about Marlon. I don't know, actually, you're looking into the future asking this question. It said, how did you convince the company to rethink the organization into data domain personas, as well as establish a chief data officer. And if I understand your question correctly, you're seeing a mismatch, an inconsistency between having a chief data officer role as defined today in many organizations, as well as having the data ownership by the domains. This is in conflict, right? Because usually the traditionally data officer role is I own the data, I serve the data, and now we're saying move the data to domains, move the data ownership to domains. And as Sina said, this convincing didn't happen overnight and is still in progress, but I will tell you what pain points actually help shifting that. First of all, the role of the chief data officer really turns into becoming an enabler, not so much owner of the data, right? So a lot of the actual investment and the effort and resources working under the chief data officer, chief data analytic officer, where we worked, were around establishing the platform that Sina will talk about that enables this kind of decentralized data ownership. We started with decentralized data ownership under the supervision of the chief data officer, with the plan of migrating that closer to the domains. But that decentralization happened around kind of identifying the domains, as Sina said, bringing the domain stewards into the picture, for the new initiatives, working directly and closely with the domain. So it is a bit of a transition that you establish that domain oriented structure in terms of the data ownership under the chief data officer, with the plan of going back to the source. So that's kind of the transitionary phase we were in, and chief data officers are under a ton of pressure organizationally when they both own the platform as well as the data, and as become the centralized blocker. So that's a good motivation for organizationally convincing that the data ownership needs to be decentralized, but data governance and data platform will be centralized under the chief data analytics officer. Sina, you have anything on that one to add?
Yeah, it was a very slow journey on that one. The way that we approached it was so it's a platform. Different people can provide different data, different consumer can provide different consumption of data. We started with similar to like if you go to an Airbnb, they're like all the different rooms that are available on Airbnb, but some of them are highlighted or approved by Airbnb. Yeah, we had a certified check mark, like a Twitter blue mark check box on some of the ones that the organization had approved on. These are the right ones. These are the correct ones. We started there, and slowly, there was a bunch of other data being produced on this by the different domains that they were not certified, but they had much more traction from the consumption side, and this started to shifting the focus on that. I also see a question about the product owner role in here. From David, which I think is pretty interesting. The people who know the operation systems, by no means they should be the experts in how the analytical data should be used. We had to actually introduce a new role to this organization called the data product owner, which their job was to be a partner to the operational system, people who know the systems, but also do product discovery on what does the machine learning data scientist need. The best job description that we found was actually product owner, because they had to actually go and discover, in this organization, in this context, the data scientist needs the data in Parquet format in this past 5 years, and they do need the real time for this specific use case. And they think about those use cases and then work with the operational system to see, how can you provide my real time? Can you give me a topic? And we're going to get to that in a bit. So it actually introduced a new role of a data product owner for each of these subdomains of the organization.
Yeah, and this domain discovery, there are a couple of questions around which I kind of categorize as the domain discovery and formulation of new data products and new domains. How do you align them? Do you align them with the source, with the provider? How do you align them with the consumer? How about the ones that you join? And of course, the data mesh kind of concept allows for all of that. You will have source aligned, what we call source aligned data products or source aligned domains that become responsible. They get formulated around the systems of origin, like those three acronym systems that you had. And those domains, providing data products that are, mostly play the provider role. And you have domains that are aligned with the consumer, and they're still providing the data, but more is, we call them consumer aligned with the consumers. For example, if I remember correctly, Sina, we had a bunch of reports that require data products that are joining and aggregating upstream data products in a way that satisfy those star ranking reports, and they become data products that more aligned with the consumption scenarios and with the consumers. And if I remember correctly, in fact, consumers were taking ownership of creating those data products. And again, data mesh, even though I know people have a hard time get their heads around this, that even though you're separating the life cycle and the schema of your data products, and you have this independent autonomous data products, that doesn't mean you cannot join your data. You can still either write a piece of Spark code that reads data from two different sources and join them on whatever parameter that makes sense, or you can have federated queries running on multiple tables and multiple systems and joining them. And in some cases, I remember very early on, we just landed on, you run your downstream code that joins data from multiple places and create a new, let's say, consumer aligned data product. And we had some efficiency issues, so we were doing that kind of out of sync with the reports. So if you have any more thoughts on clarifying these different types of domains and how we manage joining and so on.
This will become more clear as we go through the presentation, if we see how we are thinking about these data products. But the bottom line is, as people who built this platform, we want to get out of the business of dictating any sort of constraint on this. There is no science in this that, hey, do these things and here's how you get domains for every single organization. This is definitely more art. And it depends on the organization, it depends on the people. And if you put two different groups on the same organization, they will come up with two different domains. This is very similar to conversation when you do the domain-oriented design for APIs or for events. The same thing will happen. There is no science into it. As a platform, the hard part is to get away from this, to provide the abstraction so that the user can do basically whatever they want. They can align it to the source or the consumption. We can go into a much longer conversation about how did it happen at this specific client, but I don't think that is a very replicable advice for every single enterprise.
Yeah.
It's more
I think that
art.
the only generalized advice from that, because I remember you and I were formulating what are some of the heuristics to identify these domain boundaries, and every organization can set up their own heuristics, but one generalized advice is that this is a function of that federated governance. I mean, the purpose of the federated governance is having data product owners or representatives from existing organizational domains that you have to kind of come together and have established a set of heuristics and go through the decision-making process when a new use case arrives, which domain will be responding with the new data product and will have that ownership. And that's one of the things that that the federated governance sets up to do. But as Sina said, it is a journey that you will refine those heuristics, how you divvy up the ownership of the data products and the domains.
All of this being said, for a domain-oriented decentralization to work, you need to rethink your data. What do you mean by rethink your data? It means that data is not just a file somewhere. You need to take ownership of all the things around your data, which brings us to the data as a product. What do we mean by that? We are trying to avoid the dark data and data swamps by encapsulating the data, policy, code, infrastructure, all of those related things in a single unit. If you think of any other areas of software engineering, this has already happened. We encapsulate all of these things in a single unit. This is now happening to the data. What are the areas that we did for this client and we encapsulated them? You can see them in these 4 different areas: the actual data, the policies, the code, and the infrastructure. The data is the bread and butter of what we're talking about, which is the data that's coming in from the input ports of these data products that are being consumed and data that goes out. In our case, we had a bunch of different formats We had data from HL7, we have data from Fire, JSON, Parquet, CSV, Avro, different formats of data that's coming in. You have different modes. A lot of the data organization data is on batch. You think of like nightly at 12 o'clock at night, full snapshot. If the data is gets too big, we are going to do a nightly incremental update of what has changed, or in the more modern data sets, you're thinking about streams and real time, and sometimes in API, when you want to consume this data, a lot of consumption patterns were API. And each of these data come with their own semantic schemas and semantics of how to describe yourself. And there's many different ways of describing this, and different consumers in our organization had different needs to describe this data. Anything interoperability with external, we had to use Fire. And I'm not talking about Fire from a domain of Fire, the actual Fire schema. And many of the internal ones, Avro was fine to describe the shape of data. If you look at a more detailed example, so this is actually going back to the COVID vaccine data product, we had a bunch of data from pharmacy drugs, which was micro batch. We had CMS data, as I said, in Fire. We had CMS is a US health standards for some data for interoperability. Drug claims, full monthly snapshot, and real time as a Kafka topic that would come in. And also data from other source line data products that would get consumed. So that's the first piece. We want to standardize how a producer of a data describes this to get onboarded. This is the part that we are standardizing on how to consume or ingest this data. We came up with a very simple DSL or domain specific language, which says, okay, you can see it on the screen. In this example, I have a blob. It's going to be on this loading zone. Here's my schema. It's going to be Parquet file. You can think about how the other types that we just talked about would look like, and the data that goes out. So when it goes out, it is going to blob or real time or CSV or whatever the consumer needs. This is the part that the product ownership is very important to figure out what kind of consumptions does the data product need. The second piece that we want to encapsulate is the policies. Who has access to this? So if all of this data that's going out in all these topics and all these folders and all these APIs and all these fires, who has access to them? And how are they gonna be represented from the security standpoint? So security is obviously a big concern in health data. You're not gonna get, if you're a machine learning data scientist, you're not gonna get access to all of the data identified. Of course, it's going to be fully de-identified. You only can do re-identification on the case-by-case basis. The policy that describes this, that describes that this data in this specific output port is encrypted, or here's the key, or here's the organization role that can access it. For example, the clinicians or the call supports can access it. These should be handled as policy as code, and this is a part of the encapsulation that we are doing. Of course, the organizational role is not something that we wanted to own as a platform. This is something that is owned by the global organization. We are just a platform inside that bigger ecosystem. So we are using the organizational roles that they have already introduced, and it's tied to the HR. And when someone joins the team or leaves the team, it changes. But we are embedding the policy of which role assigns to what data. And you can see an example here. So if I have, this is a specific section of a policy as code for a specific data product that describes that the ML team has read access to this specific lab result ML optimized data output port. And by the way, this data is sensitive, which it's trying to abstract away all the complications that comes with the sensitive data. In our case, sensitive data had to be treated very, very differently on our storage, on our resource group, on our infrastructure, on Azure from other data. The producer of the data is just describing in a standardized way. Here is the output, and here is the policy that goes with that. The third piece is obviously the code that manages and changes this data. You can think of, I'm receiving data, so I need to process it. I want to check if this was the data that I thought is coming in, checking the schema, checking the validation, checking the quality thresholds. Any transformation, I want to join them, I want to dedupe them, I want to whatever your consumer needs. And the transformation of making these output ports. In our case, you had to abstract out the internal storage of the data from the output representation of the same data. So we had a canonical data, and sure, you can have it in API format, or you can have it in a Parquet format, or you can have it in a SQL format. All of the code that does this transformation needs to also get encapsulated with the other data and the policy. And the last piece is the infrastructure, right? We are, as I said, we built this on the cloud. We are trying to abstract away all the infrastructure that comes with a beautiful hexagon on top. And you see all of these beautiful logos of the different tools that goes underneath, enabling such thing. If you zoom in and double click on what's under the hood of one of these simple hexagons, the data comes in and the data goes out, you will see something like this under the hood, which is, I don't know if you can see all the icons, but you see a bunch of Azure utility functions like Databricks, you'll see ADF, you'll see storage accounts and containers and all of those things. And that's what's looking under the hood. A lot goes on in this hexagon, and this is the main pain point that we are trying to abstract away from the user. The user doesn't need to know all of this this ugly picture that's happening under the hood. And the reason that that this picture becomes so complex is none of the cloud providers think of data this way right now. Data, you have a bunch of different tools and you duct tape them together to get to an outcome. There are some new tools like if you look at the direction of things like Databricks or Azure Synapse Analytics or Snowflake, you can see that they're trying to make a holistic thing that works for all of these things together and bringing all of it together, but we are not there yet. And you can see in order to make a data product, an autonomous unit that is independent from other ones, you need to do some of the wiring yourself. What do I mean by autonomous? So think about if I have a data product for encounters or clinical encounters or claims, you want this to be independent from the other one. If there was a security breach in one of them, you don't want the breach to go to the other one. You want, if there is a high throughput of consumption of the people who are really using this data, you don't want the throughputs affect the other data products, which this kind of independence of these units, architecture units, really change the way that you need to think about your architecture patterns. You see a lot of Azure here. Of course, the tooling is constrained by the environment that you're in. We had a very strong partnership with Azure. And if you look at our tool set that we used for any area of this, you see a lot of Azure tooling. Obviously, this is not saying that Azure is the best recommended tool for this. I'm just saying in the constraint of this client, with the situation that we had in, with the partnership that we had, these are the tools that we used for each of the areas of creating a data product. And in order to make the autonomy of a data product, you really need to think, if for my storage, at what level of abstraction should I put my data? Is it a storage account, or is it just a folder, or is it a container? Or for example, if I'm using Databricks, do I need a cluster for a data product, or do I need a workspace for a data product? Each of these tools have different level of abstractions, right? And if you look at the documentation of each of these tools, they usually have a model that is very, very independent. For example, if we're talking about storage, and a storage account is something that is independent. It has its own SLAs, it has its own resource unit. And in an ideal world, you would say each data product gets its own storage account, each data product gets its own workspace, and so on and so forth, which brings us to the picture on the left side of this diagram, which is data product unit encapsulate all of this, and everything is very, very independent. In reality, this was not easy to do because you're going against a lot of constraints. For example, in the Azure land today, you cannot have more than 250 storage accounts. You cannot have more than 800 Azure Data Factory. And this list goes on and on and on. And of course, there are a lot of cost constraints to this too. You can do some of these things, but it will cost you a lot. So what we had to do was try to go to the right picture, which a lot of these services are abstracted out from the data product. And we had to do a lot of engineering work to create this multi-tenancy of a data products above this, so that if you are a data product and you have a sensitive data, that layer of the platform is trying to decide that where to put your data without the consumer knowing, but also share the same storage accounts because they're precious and you can't just give one to every single data product, especially at the scale that we were going, which we got to thousands and thousands after 2 years. This was a engineering heavy lifting that we had to do. I think in future, the amount of this work is going to get reduced as the cloud constraints become less, and also the tooling is embracing the data mesh adoption. But that was one of the main learning. But so the 4 things that we're encapsulating: the data, the policies, the code, and the infrastructure, that all goes together. And this brings us to the learnings from this section, which is data as a product requires a product owner. We talked about that in the Q&A of the last section. You can apply all of the product management thinking to this problem. You can think of, our teams found data product canvases that were very useful, similar to the product canvas or lean product canvas mentality. Who is my customer? How am I getting to the market? What are their needs? What are the capabilities they need? And measuring the KPIs. How is it being used? Interviewing your users. All of those mentality of growing a product applies to when you think about data as a product. And we had a lot of success in introducing that role. We talked a lot about infrastructure, so this might be a good time to pause and see if there's any questions about data as a product.
Sure. I mean, there are a few good questions. There are a couple of questions that I categorize under the umbrella of data modeling and schema. And, usually there's a good question from Lina about, how are the schemas handled when, data comes from different sources, we're sourcing from different sources. And there's a question somewhat related around how do we manage this kind of different domains defining their own internal codes for the same data sets and defining their own way of describing the data syntactically or even semantically. I mean, what data mesh tries to do is saying, and in fact, which is driven from DDD, 2 concepts within DDD, which is one, you have your domains as a bounded context, that they have the autonomy to define their data according to the reality of that domain, and they use a ubiquitous language that they use to describe that data. However, so then you translate that back to the data mesh. What does that mean? It means if a domain is responsible for claims or COVID findings, they define the syntax and the semantic of a particular data set that they own. But it doesn't stop there, because you need to have some sort of a context mapping that this data that now defined, my COVID descriptions or COVID data set might have some mapping to other data sets, because the member that gave me their COVID information is the same member that I have, their claims or their pharmacy requests. So the context mapping need to be established explicitly, and there are different ways of mapping the context between one domain to another to know this is the same policy, this is the same entity being described partially differently in different domains. One way of doing that is having these globalized, unique IDs that as part of your data modeling, while you have your autonomy to define your data according to your local definition, there are some common entities across the organization that have to be mapped to their global ID system or their global semantic. While the data sets are modeled independently, of course, there is a way, a registry and discoverability tool that allows all of these schemas being discovered. Sina, do you want to talk a little bit more, maybe pragmatically, how did you guys implement this model in your case?
For sure, there's a lot goes into that question about how we approached it. But to your point, what we did was implementing some sort of a model registry, which these different producers of the data are defining their model in that, and there is lineage between these different models. So if you're consuming some sort of a data from another source, from another data product, there is a lineage about this schema was derived from the other schema. There is a lot of gap in the tooling industry around this. The best that we found, and we can talk about this more probably in the governance section. We found a lot of good tooling in the health industry with the FHIR standards that allow you to do this. You can define schemas and can drive schemas from the other schemas, and there's some sort of a lineage and inheritance between these things. These things get a little bit harder to do with standards like Avro and JSON. And so that the tooling, there are still tooling gaps there. Let's pick this back up in the governance section. I'm just worried about time. We can talk more about that thin layer of governance to ensure something like some stuff like this.
Yeah, and there are a couple of good questions that I think that are segues to your next part, which is, data mesh is not a platform. We're talking about building the platform. What do we mean? Data mesh, in fact, does have a component of that is called self-serve data platform, which means a collection of services that enable reduce duplicate work. There was a question around reducing duplicate work. It has a component that abstracts all of this complexity so the customers can do what they need to do. And there's a question around, shall we just duct tape the existing tools that we have, like this, Databricks, CI/CDs, and so on, or building a refactoring out and building a platform? I think what we did, and I don't think you have any other choice, is use the existing tools. But what we did very early on, we created a set of APIs and a client tooling, client command line and interfaces that Sina will show, that abstracted away how those tools and utilities actually being duct taped together, or how the tenancy model that Sina shared is get provisioned. So create those APIs to your platform early on, and then implementation behind it can evolve. And we changed the implementation of this platform probably 2 or 3 times across the course of this project, but we have no choice but the existing tools. A little bit more friction today, probably that's resolved. So maybe that's a good segue to move into the data.
Oh, for sure. Because without removing that level of complexity that we just showed, no one can produce data for the rest of the organization. So let's get to the self-service platform. We talk about 3 different groups of experiences when we talk about this. We talk about the data mesh experience planes, things that go across the whole network of mesh, and the specific data product experience plane. These are not, by the way, hierarchical. These are just groups of different tools. And the last one, the utility plane, which is the raw cloud provided tools like ADF, for example. Let's start with the top one. Like, what does self-service platform mean for a mesh experience layer? When we were going through this journey, we had to introduce a lot of new concepts. Data product, input port, output port. There's a lot of new words being introduced to the organization. We had to draw a lot of parallels between things that people already know and feel with the new concepts. For example, autonomous data product, it's something on a cloud, like a cloud object. Like if you have a file on your drive, think of that as a consumer. Or a developer experience for introducing. A lot of people have used NPM and Maven and things like that. Let's borrow some analogy from those kind of developer experiences for a data product developer. Access control is similar to sharing. Organization by teams, think of drives, polyglot data output formats that they can output as a Parquet or CSV or JSON or whatever. Think of that as an export function. You will see that in the human-centric design of the user interfaces that we did for this client. Back to the data mesh experience, there are three main products that stand out when you're thinking about the whole mesh. The admin console, which is the internal for the operations of the team, the observability for what's going on the health of the mesh, and discovery, which is I want to use what's here. In order to enable innovation, I need to know what is available to me, so I don't duplicate, so I don't go around and ask people for what's already available. Let's start with the discovery, because I think that's the most interesting one, at least to my point, which is, okay, I want to be able to search, tell me what are the data products available. If I search one of them, I need to know what are the output ports, how are the schemas for each of these ports, what are the data quality metrics for them. Of course, I probably don't have access to this right now, but I should probably have a request access button so I can go and ask for access. And if I don't have access, at least show me a data profile of how the data is distributed, which is the most anonymized way of looking at the data, so I can get a sense of, oh, so this one, the value distribution for a date is between 91 and 2020. Okay, I guess this is the right data or not, before I go through the access request and go through all of that. There are a lot of tools in the industry that are playing in this field, Atlas, Purview, Collibra, Data Hub, like there's so many of them. At the end, and we did a bunch of POCs on trying to use these tools for our purpose. At the end, we had to roll our own tooling because of a bunch of constraints on this specific client. One of the main things that we wanted to do was, if I'm looking at a data product as a consumer side, I'm an analyst or I'm a data scientist, I want this data to be actionable. I want to be able to do something with this data. And that was like, if I'm looking at this, I should be able to launch it in Power BI or launch it in Databricks or launch it in as an input to another product. Or sometimes, no, I just want, just give me the connection string. And I'm gonna use my own client to use the data here. You can see an example of launching in the Databricks. So one of our main users was the machine learning data scientist. They, of course, most of them work in the notebooks environment these days, and they use Databricks heavily. As you can see on the code, it's a lot of, if you can see that we have a data product client, which is abstracting away a lot of authentication and discovery and data quality metrics for you as a user. So you're just interacting with the SDK to play out with the data. But if you say I want to launch in Databricks, this is the kind of actionable thing that you will get when you're trying to use this data. If you go back to our COVID example, you could search for any of the data sets that were input to this. So the drugs that we talked about or claims that we talked about, all of those things, you could search for them. You could view them here. And the journey of doing an analyst work starts with a discovery. This is the place that they go to start their journey of thinking about, I want to consume some data. The other side of the coin is, okay, I have all of this data, but how is the health of these data products? And that's where the observability tools come into play. Show me dashboards of how healthy these data products are. And by healthy, I mean, show me the anomalies. Was data supposed to be every night, but it hasn't come for the past 48 hours? How is the health of this data? Or the last increments, the increments are usually a 5 gigabyte into a terabyte. Last night was only 100 megabytes. What happened here? And show the trends. There's a lot of tools industry. Again, we ended up just using pure Azure Log Analytics and mining this data and creating a bunch of dashboards on top of raw log files. The main persona that was using this tool was the operation support, L2 and L3. This was the main dashboard. We also built a bunch of integrations with ServiceNow for alerting and escalation and on-call rotation and things like that for routing the alerts to the people who build those data products. And the last one, the admin console, which is trying to, one of the main, there was a bunch of things on the admin console, but the main thing was access management. We talked about the data stores originally, which they are enabler of being able to certify the data and manage access to the data. They are the main users here, that they would see the different access requests, and they should be able to do two things here: manage access to who can look at the actual data in the output port, and accessing to who is the team who is behind this data product, who's the owner of this data product. These two things are the main use cases for the admin console. In our case, these two accesses are two separate policies, two separate universes. If you are in the position of saying Sina can access this data, is a very different thing from saying Sina is a data product developer on this data product. So catering to different tools. There's a lot of tools in the industry for this, Privacera and Ranger being one of the most famous one that allows RBAC, role-based access control, on your data. We really wanted to use it. Unfortunately, we couldn't. It actually matched our use case pretty perfect. The challenge was, because of a bunch of regulations that this client had, you can't, the access to anything on the whole enterprise had to go to a centralized location, and you cannot distribute that part. This was a contractual obligation that this organization had, and their tool was Azure Active Directory. So we ended up building RBAC on Azure Active Directory, which has also a lot of interesting challenges when you have Azure Active Directory on-prem and on the cloud, and the way that they sync, and we can talk about the challenges there in another time. These were the main three products that would talk when we talk about the data mesh experience. That's the main three products. The other side is, okay, let's talk about a specific individual data product. I want to be able to manage the life cycle of that. You see at the bottom of this diagram, you see the core layer, which is the API that Zhamak was talking about, which is the abstraction that all the duct taping and all the legacy and all of the things happen behind the scene. And you see a bunch of tools on the top, which we had to build for this specific client, like BYOD. I'm not going to get into the top tools. They are very context specific, but I wanted to show that if you build your abstraction layer right, you can extend these things to other GUI tools. The core layer is a product that offers API and CLI experience. If you look at how the CLI experience would look like, again, borrowing from existing industry analogies like NPM, on the left, you can see I'm making a folder, I'm initializing a data product, which gives me a sample, a specification file. The specification file is the abstraction layer that the user is defining to the platform. If you have used any other platform, if you're using AWS, your abstraction layer, I guess, is the CloudFormation JSON file. If you're using Kubernetes, is the YAML files that you pass to your Kubernetes. The spec file that you see on the right side is that abstraction layer that we built. We can see a specification for inputs and outputs. This should sound familiar. We talked about this when we were talking about the standardizing inputs and outputs and policies. You get a sample a specification, you can change it, of course, delete it, move it however you want from your inputs and output perspective. And at this point, you have defined your data product, but it doesn't have any physical manifestation. It doesn't have a storage account yet. It's not real. It's just a design artifact. And we borrowed a lot of analogy from things like Kubernetes. When you have a definition of a data product, you can now say, I want to deploy it, or I want to run it. And when I'm saying I'm getting a specification and I'm deploying it to an environment, I can say deploy this to staging or production, or I have a promotional path, a typical CI/CD promotional path of a product, and then be able to run a specific deployment. So if I have deployed this specific version, this specific environment, I want to be able to say, run this based on the data that you already have, or with sample data, or create some synthetic data, or wait for the next event that triggers the run of a data product. This was the CLI experience. The API behind it will look something like this. You have your the domains here in the context of building this software, the domains are your data product and policies and deployments. You can see the data product domain here. You can do gets on them. You can look at the versions. You can query them. You can post a spec file and create a new one. And when we talk about the deployment and runs, you can do the same thing. If you have a data product as defined, I can now look at all the deployments that have already happened, or look at all the different versions, or be able to run these data products, which run all the pipelines that are behind from getting the data from the input ports and waiting if you have multiple input points, scheduling that in a way that is efficient, run this and create the data in the output port, and do all the side activities like publishing information for the discovery, because the discovery should know about this, right? Or publish information for observability, because observability dashboard needs to know what's going on, and when was the last data quality check that ran on this specific data product. This API was the abstraction. As Zhamak said, we had to rebuild things behind this multiple times as we learned more and our environment changed, and our infrastructure changed in this journey. But the abstraction pretty much stayed the same. It didn't change that much. It evolved a bit, but not that much. The main learnings again are around the cloud offerings are not there yet in terms of providing this kind of functionality. This requires a lot of engineering work and investment, which means some of this kind of platform building may not be suitable for everyone. There is some amount of innovation that requires to happen here. And one of the challenges that we had is the balance of the capabilities with the data mesh and the data experience plane. We started with building that API abstraction layer because we wanted to have that shim over the implementation. And at some point, we realized that we had not invested a lot in the experience layer, which caused a bunch of troubles for us, because if you don't have the experience layer, at least the basics, there is no view. There is no one on your executive committee can see what's going on, or even on the consumer. We had to shift some of our priorities to invest on the experience side, because otherwise your operations team is suffering. Your consumer is looking at a bunch of Excel sheets again to figure out what's going on, and balancing those two things were challenging. This might be a good time to stop and see if other questions about what does a platform look like for a mesh.
Yeah, I think some of the questions, the snippets, I think had triggered some interest, but as you went through snippets of specs that you had shown, but as you went through showing what the purpose of it, how it was used, it was answered. But I would just add on that kind of specification and APIs that Sina showed. There is a ton of learning in the operational world around provisioning in a declarative manner, as in you want to allow your users, in this case, data product developers, or even data product consumers, to declaratively tell you what's the target state of the thing they're building should look like. Like in this example, Sina showed the target state of a data product, the snippets of it, has this inputs and has those outputs and has these policies to be enforced. And it's really, that's all a data product developer tells. And behind the scene, the platform knows how to imperatively go and implement and assure that target state is always up and running. And that's the learning from Kubernetes, and we just applied it here. But note that not everything should be declarative. And there's a point of declarative despair, which is when you try to turn your code, your transformation code, to a bunch of declarative steps, which tools like, ADF and, Azure Data Factory and so on do. That is not where we encourage you to declaratively tell you the target state of your transformation. I think we encourage you to actually write code. As Sina showed, there was a snippet of code for pieces of your transformation that needs to be just coded and described as how the transformation needs to be done. And there's just a transformation engine, in this case, a Spark, that would just run that transformation. So I think that's just two of the design choices that you kind of learned if you build any other kind of platforms.
Yeah, we didn't go into that in this presentation, but the a standardization for the input and output was very easy to show. But the transformation part is actually pretty tricky. We started with just basic Scala jobs that any developer could run on their machine with some test data, and then you would deploy it and it would run in the Databricks environment. This evolved into more notebooks driven approaches where our users were much more comfortable going to Databricks, playing around with a bunch of things, and then here's my transformation. And there was a bunch of challenges in capturing that transformation. Because we were on Azure, the other kind of transformation that would happen is people would take things into Azure Synapse Analytics, which has changed its nature over the past couple of years. But the latest version, similar to Databricks, similar to Snowflake, allows you to do a bunch of these transformations, and capturing that kind of transformation and embedding it inside the transformation part is the challenge that we are going through right now. The need for this kind of IDE environment so I can do this transformation is evolving as our industry is changing a lot. And I think it's one of the most exciting parts of working on this, because you're bringing some basic software development engineering practices to these notebook-driven approaches of playing around with the data. When you have test environments and CI/CD, and things are applicable and things are versioned and things like that, which is, I get pretty excited about those things.
Yeah, and there was a good question around, in a large organization, when if you try to centralize the platform, there would be a population in your organization that does not want to use the platform, or the platform doesn't meet their needs. And we recognize that, we ran into that. We had a very evolutionary approach, intentionally designed evolutionary approach as what the bootstrapping phase of this platform looks like, who are the customers, how many users, what's their needs, what's their population. We're not trying to address, the whole universe of the, needs and requirements. And then as we go through, expanding and scaling the platform, again, how do we shift the platform capabilities to diversify and so on. So, and the people that didn't want to necessarily didn't, either need to, or they had different needs in terms of the interface of the platform. I remember that we kind of expose the utility level to them, right? So that they can compose the tools that they want, however they want. But those are kind of the outliers, and they're probably the 20% and not the 80%. So we try to optimize for the 80%. The platform is fairly opinionated, and if the needs, but it also exposes those utility layers. So if people don't like the opinionated way of the platform, they can still get access to those utilities that the platform team still provisions and monitors, but they can work at a lower level and compose their experiences however they want.
Which brings a bunch of different trade-off conversations around, do you want to allow that or not? But you need to have some flexibility. It has some costs, obviously, because now you're losing the standardization. This actually became a problem for us because of audit requirements and compliance requirements, because if you go and do your own utility function, there is no way for us to ensure the governance in an automated way, which might be a good segue to talk about the last piece of this conversation, which is the federated computational governance part. Let's define these words a little bit. What do we mean by that? The governance standards for business and technical policies for cataloging, securing, and managing. Federated, decentralized. It's not a centralized team who's doing the governance. And computational, policy as code and make it automated. The way that we approach this, when we started our journey, there was an opportunity for going to the cloud and cleaning up a bunch of hidden skeletons in the traditional IT organization. We had a lot of legacy over the 30, 40 years of business on the on-prem managing of access and managing of data and models, which the organization did not want to replicate in the cloud. So we wanted to clean that up. The governance organization, typical to a lot of organizations, is there to look at what you're doing and penalize you if you step out of the line. If you do something bad, if you're exposing some data that is putting the organization at risk, they have policies and standards and processes to tell you that, hey, you did something wrong, or come to me and let's do a review together and things like that. although this organization had done a bunch of cloud experiments, they were still new to the cloud. Like none of the experiments had, for example, PHI and PII data on the cloud. So there was a lot of learning curve about the governance organization trying to figure out where do we fit in this picture? How should we enforce the mandates that we have for handling sensitive data on the cloud? The way that we approach this, if you look at what happened in practice, was instead of having the governance as a sitting alongside with the teams, if you look at what happened after this transformation, the governance rules became embedded as a part of the self-service platform that we talked about. The governance team became a stakeholder in the design of the platform. The one example that stood out for me was, for example, if you think of like the same conversation, handling sensitive data or handling segregation of data between different legal entities. There's a bunch of, at least in the US, there's a bunch of rules around how do you handle data that are from different legal entities on your layer. Of course, the contractual obligation never gets into the level of detail of on Azure, it should be like this, or on AWS, it should be like this. It is the job of the governance organization to enforce these policies. So what we did was having the governance teams as the stakeholder to this platform, instead of the slapping your hand and saying you did something wrong, come and design this with us. And if you put the tag that this is sensitive as a user, if you do that, if you're defining this as sensitive information, then in an automated way, the data is being segregated and the sensitive data is being handled the way that you want in an automated way. And there is no room for error here. It's always going to work. There is no need for an after process check. Sure, if you want to do a one-off checks and ad hoc checks just to make sure, you can still do that. But your role is no longer the policing. Your role is come and be a stakeholder and inform our team about how it should be designed so that we don't break we don't end up on the news, and we don't have to put something on our website that our data was breached. There's a bunch of other examples that comes to our mind around how this shift happened. The adjustment of sensitivity, for example. How was it handled in the data catalog versus if you define it in a declarative way as a platform will handle it for you, or the network policy. So this was Azure, this was a hybrid cloud. This is not a public cloud 100%. There is a bunch of policies around this kind of data need to be on-prem and cannot be exposed through public internet. In a lack of a platform and automated governance, these kind of rules, imagine if every team needs to think about these rules, you will come to a complete halt. Managing network policies about your private link, private endpoint on Azure, it's not an easy thing for everyone. So abstracting this thing out under the hood of the on the self-service platform as the automated governance to enabling your team to focus on what they are the best at doing and not worrying about cloud or Azure or things like that. They focus, let them focus on the domain that they really know the best. Other than automating this, the mentality that we had going through this was, what is the thinnest layer of automation that we can do? Because we don't want this layer of governance to become so big that it's also, again, we will fall into the same trap. If you look at what does this thin layer look like? For us, this was these 4 areas. What are the schema languages that people are describing the data? We talked a little bit about lineage and how you map if you're using another data, or if you're changing some data, how do they map with each other? And there's standards about that, and the AVROs and FHIRs and all that. The trust boundary of data products was another subject that we had to have clear policies. What I mean by trust boundaries is if you're using the data of the platform, if you're using the data, I'm delegating the trust to you. So from now on, you have to implement your own rules. If you're staying in the boundary of the data product, then okay, ensuring that these policies are met are a part of the platform. making these lines very, very clear about where the data leaves the platform and what are the boundaries. Those boundaries were very, very important. Identity on the mesh, Zhamak talked about this, about how do you ensure if Sina has an ID, what does this ID mean? This ID can come from the warehouse, can come from a transactional system, can come from anywhere else. How do you manage IDs that are global, that all of these data products in your ecosystem need to talk the same language because you're gonna join them at some point. And then access control. We talked a little bit about this, about the role-based access control. This was a thin layer for the automated governance. As you probably can see, we didn't talk much about the federated parts. In this client, we didn't tackle the federation that much. The thin layer was the one that we put most of our efforts on. Most of our learnings are around these areas. And I think we have covered all of these three so far. The changing role of organization from enabler, making them enabler instead of policing you. And yeah, I think I've covered all of them. I'm just looking at time. And let's just wrap up and then see if there's time for more questions. So bring it all back together. The key lessons of the 4 principles. For domain ownership, you need a sponsorship and alignment between your tech and the business teams. Do this early as possible. If you don't do it early, you're going to be in the trap of becoming a centralized team. There is no way around this. You need that sponsorship and that alignment. Data as a product, it's not only about the data. This is the biggest mental shift. It's not just the data. It's all the things that are around the data that needs to be encapsulated as a cohesive unit. Self-service platform, this requires a lot of product thinking, internal platform building. There are a bunch of recent articles and books about this. It's a little bit different from a generic product management practices. And the federated governance, which is the shifting the governance to become a stakeholder of the platform as opposed to checking if everything is okay all the time and penalizing you if you do something bad. That being said, if you want to learn more, there's a bunch of more of these articles on our website about this. And do we have time for questions or no? 1 minute.
We have 1 minute. Why not? So I think there is a good question around incentives that, how do I incentivize these domain teams that have no interest of writing a bunch of ETLs to satisfy analytics? And I completely agree with you. The job of those teams is not about writing a bunch of ETLs. The job of those teams is about, creating data products, and that becomes part of the responsibility. Similarly to writing the APIs and running the applications, and you can incentivize teams initially artificially by introducing a bunch of incentives around the data products that you're serving, the number of data products. In fact, this particular company had the number of data products as a measure. I know there are some downsides to it because it's kind of a vanity measure, but it was a forcing function to get these domains generating the data products. And it was something that had gone all the way up to the board. Like they had recognized the data products is the kind of the investments that they're making. And I think ultimately the real incentives are embedding ML and analytics in every one of those applications and every one of those domains, that they not only need the data to provide the data, but also need the data. They're the first-class consumers of that data to embed ML in their function, and that's ultimate. I think the human needs would be the ultimate incentive. We answered a lot of questions, Sina. Thank you for the presentation. Thanks everyone for coming, and we will have the recording of this online very soon. Yeah, and good luck wherever you are and wherever you are in that journey with your data mesh. Thank you, Sina. Thanks, everyone.
Thank you.